Now we're going to get into the inspection of a vapor control system. Now, a lot of these vessels carry a lot of very dangerous cargoes that emit very unhealthy vapors that would pose a serious health risk to anyone who inhales them. So as a result, obviously, we're going to be conducting these inspections in our standard PPE as we should on any other inspections, and just being mindful of the vapor hazards that are involved. So in this portion, we're going to discuss the actual vapor control system approval letter and manual as it pertains to the specific platform we're on now, being a barge. They actually have neither. They have a vapor control system PRIS approval. So it'll actually be a plan review information sheet approved by MSC. But the nuts and bolts, really the approval letter and the manual, you'll find primarily on the deep draft ships themselves. That'll be a Coast Guard approved letter approving the system itself, as well as an approved manual outlining the operation of it, how everything's used, and the hazards involved. Now we're going to be discussing the actual markings on the vapor piping itself. It's pretty universal across the board, whether you're on a barge or a large tank ship. It's going to be very similar. It's pretty much pulls from the same regulations. It's going to be the red, yellow, red painting on there to distinguish the piping from any other cargo piping on the manifold. In addition, you're going to have 2-inch black letters, vapor, stenciled on the side, again to let you know the purpose of this pipe itself. So now another unique aspect of the vapor control system on the manifold itself. You're going to be having a flange stud here, which is required. That's just another safety measure taken on this so that when they're hooking up piping to these manifolds, you're not pumping cargo or anything else. You cannot confuse any other system with this. Anything that's going to connect will have a hole to receive that stud so that you're not confusing any hookups, and you can ensure that the vapor control system is running to the right piping. Next, we're going to be taking a look at the drain line installed on the piping itself. Pretty much we just want to take a look, make sure it's in good condition, and that it'll operate as designed. You want to usually see these installed at the lowest point on the piping system because the main function of it is for when condensation and anything builds up in there, you want to be able to successfully drain it out to prevent any corrosion inside. So obviously you want to let gravity take its course, ensure that it's at the lowest point in the piping, and then of course just check to make sure that they actually have one installed. There will be times, especially on barges, you see that it hasn't been installed. So obviously just checking to see its presence and its function and that it's in good operating condition. Now we're going to be getting into ensuring that the vapor control system meets electrical requirements and verify that it is electrically bonded. Purpose for this is obviously ensuring with all the friction from the vapors and gas moving through the system, static electricity gets built up that needs to have a place to go so nobody gets injured in the process. The majority of the time with these barges, the common trend, at least I've seen personally, is that the facilities end up rigging up that entire system to make sure that it's bonded prior to cargo operations. So there's nothing for us to really point out at this time, but it is something to make sure you look out for and ensure that the system has the capability of being properly electrically bonded. Now with sometimes highly explosive cargoes that are carried in a lot of these barges, tankers, what have you, obviously the environment within the cargo tank has the capable of being a very explosive environment. So you need to have the means to either input inert gas or create inert gas through an inert gas system on vessels like these barges. Predominantly, nitrogen's pumped from shore to ensure that the tanks are inerted. When you get onto the tanker side, they'll have systems on board that are able to supply that gas itself. Unfortunately, on the barge here, on this one item on the student guide, we won't be able to locate an IGS isolation valve, but that's something you'll be able to see on these tankers. And just to harp on the importance of being able to identify that valve and ensure that it's in proper working order. But that'll just be something that down the line you'll be able to get with your verifying officer and be able to see yourself. Next we'll get into discussing verifying the closed gauging system. There's three levels of gauging that you'll be becoming privy to as you go on, starting at open, restricted, and now closed. It's kind of a tiered system moving up to, depending upon how hazardous the cargo is. When closed gauging, it's ensuring that there's no ability for the cargo to interact with the individual working on board. An example here is this sight glass can be used to visually gauge the level of the cargo. When you're inspecting it, you want to ensure all the bolts are fastened properly and that there's no capability for vapors to leach out while an individual may be peering into the sight glass. So again, focusing on these cargoes that require vapor control, a little more hazardous, will require the closed gauging, and you just want to be ensuring that the closed gauging system itself is operating as it's intended. Now we'll be moving on to visually inspecting the vapor line itself internally. To properly do this, we'd be popping off the actual face here and being able to look internally. Generally speaking, you're just taking a look at the obvious signs of any damage, corrosion, ensure that the vapor line itself is in good serviceable condition. For vessels that may have carried polymerizing cargoes, you can get more into detail with that later, but the nuts and bolts of that is, over time, there will be formation of solids inside. Obviously, when you start introducing solids inside of a vapor line, pressure is going to increase. Obviously, increased pressure is not a good thing. They're approved for just a certain pressure. So that's just one more thing to be taken a look at when you open these up and take a look inside. Kind of dialing back into approvals and everything that goes into these systems and getting them approved. They're rated up to certain flow rates. That also obviously speaks to pressures and everything else involved in the system. So when you're out here inspecting them, you're going to want to make sure that, number one, the maximum flow rate has been determined and approved. And then crew familiarity, you want to make sure that the people operating the system know what that maximum flow rate is and are able to properly monitor and control it. Now, another document that inspectors will come out and take a look at concerning the vapor control system is the vapor tightness test or certificate. Kind of just confirming that annually this system has been tested to withstand certain pressures. And additionally, you want the pressure sensing device, just this gauge here, located as close as practicable to the vessel vapor connection itself. And as indicated here, you're going to have both a positive and negative pressure, obviously depending on what evolution you're conducting on the vessel itself, just to ensure that you're within the allotted ranges and that you're not exceeding. And in the event you are, there need to be alarms that sound. That's another test that they can check to ensure that everything on board is being conducted as safe as possible. Now, to wrap up, just some tips and unique considerations to keep in mind when dealing with systems such as these. A lot of the times when these are introduced, you're dealing with very dangerous cargoes, the vapors of which are a serious risk to human health. Now, whether they're controlling these vapors by sending them to shore or venting to air, you just got to make sure you rely on your shipmates, be very diligent with your surroundings. You just got to pay close attention because the last thing you ever want to be doing is breathing in these vapors. So while you're inspecting these ships, all I can encourage you is just to make sure that you're being as safe as possible, paying full attention, and just make sure everybody gets home safe. Now, finally, we'll run through a brief summary of everything that we've discussed today when it comes to inspecting a vapor control system. First, we identified the hazards, cautions, and or required PPE when inspecting these systems. We verified the VCS approval letter and approved manual. We verified markings on the vapor piping itself. We verified the presence of the required flange stud. We inspected the drain line. We verified that it had the capability or is electrically bonded. We verified the presence and operation of IGS isolation valve and indicator, if applicable, not so on this barge. We verified the closed gauging system. We inspected the vapor line via internal visual inspection. We were not able to actually look inside, but the items you need to be looking at, we discussed. We verified the VCS approval and maximum flow rate, verified vapor pressure test results, and we went over any unique tips or considerations for inspecting these systems. Now, if there's anything additional that you want some information on, obviously I understand there's a couple things relating to these systems that you're not able to see on the barge that we're on right now, but you'll be able to see on these deep draft tankers. You can bring that up with your verifying officer, and we'll get that taken care of.